Okay, so in the last session we discussed about some basic, you can say the means basic introduction of the AI ML for the practitioner, right? So now in this particular session we will discuss. We know that there is when we talk about machine learning, there is the supervised machine learning, unsupervised machine learning, and reinforcement machine learning as mentioned, right? So in supervised machine learning, first we will focus on the regression. Regression means we want to predict some continuous number, right? It may be the price of house sales, and you can say the yield. Okay, so that type of the thing we can predict. So in this regression, suppose what's the problem? Here you can see, suppose you are thinking of selling your house or your home. So here we have some historical data of house selling price with respect to the size of the house. Okay, so what I will do first means suppose just assume that what will be the price of my house, or you can say your home size is 300 square feet. In that case, what will be the price that actually we want to identify with the help of the regression. Okay, and now if I want to solve this particular problem with you can say the linear regression. Okay, so how we can solve this particular problem with linear regression, that we will try to understand, and then also we will check the accuracy of the result. Okay, this linear regression actually work to predict this particular house price or not. Okay, so now we have this data. What I will do, I will do the best fit line on the basis of this data. So first I'm just trying to solve this particular problem in Excel, and I'm trying to give the some basic idea. Then in the next session we will take the some real means a real life data, and we will do the some prediction, right? So here what is the process, means how machine will identify for the home size 300 square feet what will be the price. Okay, so what I will do, I just try to plot the scatter graph with this data in the initial stage to understand what is the relation between the size and price. Okay, okay, so it will show the relationship between the size and you can say the price of the house. Okay, so here you can see that there is a positive correlation present between the size and the price. Okay, now the next point is if there is the positive correlation present, then the next what I will do, I will draw the best fit line. Okay, and best fit line means just add the, means I'm just talking about the linear regression, so I will take the linear line from the Excel, and there I just pass the if you see, 1 minute, I will select the line, right click. Okay, so now what I will do, I will select all the point, then right click, and there is the add trend line, and there I will select the linear, because we are talking about the linear regression. And if I say display the equation and display the R square value, means the R square here suggested that you can say that is the 0.96, means this particular line able to explain the variance of this historical data. There means able to explain 96% of variance. Okay, now this equation is nothing but you can say y is equal to theta 1x plus theta 0. If we say the equation of the line, okay, so if we assume the equation of line is equal to h theta x is equal to theta 0 plus theta 1x. Okay, so in that case, can you tell me what is the theta 1? The theta 1 in this line, this is actually best fit line, and the for best fit line, what is the value of theta 1 is 0.03, and what is the value of theta 0, that is the 175, and this particular line able to explain 96% of variance. Okay, So now with the help of this particular line I can easily means predict what will be the price. Suppose if I pass means y is the price, okay, here in this line you can say the y will be the price of home, okay, and x will be what, x you can say x is equal to the size of home, size of home, okay. So if I pass in this particular equation, suppose this is the equation, in this equation suppose I will pass what is the value of x, okay. So suppose 0.321 and suppose my house size is 3000 square feet plus 175, okay, then I will get the output, and the price of the home will be, if it is right, 3000 square feet, okay, actually it's 0.03271. So the price, you can say price of the home, okay, which I want to sell, that will be the 271.3 dollar, okay. So any doubt till now, class? So the next point is this is the approach to solve the problem, okay, regression problem. And their machine first will be identify the best fit line. How to identify the best fit line, now that part I will discuss quickly. Or instead of discussing that, we just try to solve this particular problem with the machine learning philosophy, okay. So just assume that I have this data set, okay. So just I'm writing here machine learning method, and there you can say linear regression, okay. So now these are the some data set, okay. So what I will do, the first whatever the data I will get, these are the structured data, okay, and these are the data I have, and on the basis of that I want to predict the price of the house, okay, and that may be the price of the house of 300 square feet house, for this what will be the price, the price that I want to predict, okay. So now the what I will do, the first this part I will take, means the approx this data I will take as a training, and the remaining data means I will divide the data into the two parts, that is a machine learning approach. This will be the test data, right, the train and test data. Now what I will do, on the basis of this train data I will make the best fit line or model, means I will do the training process, and on the basis of this testing data I will evaluate the model accuracy, I will evaluate the model accuracy. So now if I just click here and what I will do, I will insert the scatter graph, okay. Now on the basis of this data what I will do, I will add the trend line, means best fit line, linear best fit line actually I am passing because we are talking about the linear regression, and there also I will display the equation and you can say the R square value on this train data, okay. I hope it's clear. Now how to do, means obviously means when we pass the train data it will give the 96% accuracy. R square means you can dictate that particular thing as a means that particular parameter you can assume as a accuracy of model. Now the next point is means I just want to check the accuracy of the model, and I will check the accuracy of the model on the test data, Okay, that is more means that will give me the idea that that particular model is the good fit model, or it is not giving the right result with the some unknown data, means how it will perform with this unknown data that I want to see. So what I will do now, for that we know that what the process means. If I quickly, so I will pass this testing data in this particular model, and I will check okay, what is the difference between the, and what is the gap between the prediction and this actual value. Okay, and on the basis of that I will calculate the R square, and R square will give me the idea what is the accuracy of this model. So before going to this particular part, I just want to give the some idea, okay, how this best fit line actually created by the machine. Okay, okay, so that particular part we will discuss. So now the first point means when the machine will create this best fit line, so machine try to minimize the cost function. Okay, so now what is the cost function? That is the next point. So now here you can see this is the cost function, means if the equation is this, with the help of that we can do the some prediction. That is okay. Now cost function means what? We will make this best fit line, as you can see, okay, what presented here. So this best fit line, how actually we create. So there is the function, means cost function means, you can say in short, the function that means create. Okay, so I can say like that the difference of the predicted value okay with the actual value, that if we square. Okay, and in short you can say the sum, residual sum square error, okay, of mean, or if I can take the average mean of residual sum square. Okay, so average mean of residual sum square, that I can consider as a what, as a cost function. Okay, I already written here. So cost function is nothing but, you can say, average mean of residual sum square. Okay, why? Because the here average mean of the residual sum square on the test data, no, I'm sorry, on the train data. Okay, if we will reduce when we plot this best fit line, that time this is the cost function, and cost function means what? This is a predicted value, the gap between the predicted and actual value, means we need to draw the line like that. The gap between the predicted value and the actual value should be minimum, and on the basis of that, what we will do, on the basis of that, if the value of this cost function is minimum, it means what? So in short you can say the average mean of the residual means what the error means you are getting on the train data. Okay, so machine will identify the gap. Okay, it will draw the different line and try to identify where I am getting the minimum gap. Okay, so ultimately machine will try to reduce the cost function. Cost function means reduction means what? Means machine is actually trying to reduce, you can say, the gap or error between the actual and predicted value. Okay, so this is the predicted value and this is the actual, that will check by the machine. Means this line actually is the predicted, and this you can say this dot is actual value. So machine will see where is the best fit. Okay, and if the cost function value is minimum, in that case you can say, okay, that is the best fit value. So I will show some video that will show, okay, how machine is actually able to identify the best fit line. Okay, okay, so now you can see this is the cost function, and ultimately cost function means what? That is the function, okay, that shows the gap between the predicted value and the, you can say, on the train data. Okay, I'm just doing the thing on the train data. So it shows the cost function, it shows the gap between the predicted value and the actual value. Okay, so now if the gap between the predicted value and actual value is minimum, in that case that is the best fit line, right? So that minimization actually done with the gradient descent, and gradient descent is a very simple thing. Here you can see this graph is actually plot, and when we theta 0, theta 1, all the thing we will consider. Here this theta 0, theta 1 means what? That is the hyperparameter. With the help of that we can reduce the cost function. So here you can see this is a gradient descent, and machine try to identify the minimum value of the cost function. So where is the minimum value of the cost function? Is this. And if we minimize the cost function, it means what? We are actually minimizing the gap between the predicted and actual value. Okay, clear? Okay, so now I will just show the some videos, just 1 minute. Okay, so in this particular video you can easily see this is the cost. What is the cost function here? What is the value of the cost function here? Is 82. Now with means when we run the gradient descent means what? It will check by changing the theta 0 value and the theta 1, it will check where I'm getting the minimum cost. Okay, so in short you can say that by changing the hyperparameter, it will see where I'm getting the minimum cost function. So now you can see it try to reduce the cost function by plotting the different best fit line, different lines, and here now you can see the gap between the prediction and actual is minimum. So like that it will check. Okay, so I will again show the one more video quickly. You can see. So here the equation is equal to y is equal to mx plus b, and here you can see in this particular graph this gradient descent is there some with the help of the slope, or you can say the some derivative, it will try to identify the minimum point, or if it is a OR problem, means minimization of the cost function. So here minimization of the cost function will be done, and minimization of the cost function, there you will get the where I'm getting the minimum value. So there you will get the specific m value and the b value. At a particular m and b value, or at a particular hyperparameter theta 0 or theta 1, I will get the you can say the what you can say, I will get the best fit line. So if I play this video, you can see it will check the minimum cost function, and when it reaches to the minimum cost function, you will get the best fit line. Okay, I hope it's clear. So now on the basis of this gradient descent method, we minimize the cost function, and with the minimizing the cost function, we got the value of theta 0 and theta 1, that if we put, then that is the 0.032, and this is the 175, that is the, you can say, the theta 0. Now the next point is how to evaluate this particular accuracy R-square value is actually on the trained data, but how to check the real accuracy on the unknown data, that is I not pass during the training process. On that I will check the accuracy of the model. So what I need to do, I need to calculate the R-square, right? Okay, so what I need to do now first the cost function means the minimization between the predicted and actual value. Okay, so that part we can do with the help of the gradient descent, and gradient descent will give me the value of the theta 0 and theta 1 at that particular point. The cost function is minimum, so that theta 0 theta 1 I will use to make, as the machine will use to make the, what you can say, this equation. Okay, so in this particular equation, can you tell me what is the theta 0 and what is the theta 1? So in short, you can say the theta 0 is intersection at y-axis, that is a 175, and theta 1 is the slope, that is the 0.0321. Now What is the next process? I just want to see how this best fit line is perform on unknown data. Unknown data means the test data. Okay, so for that I need to check the R square, okay, on the test data, because on the train data R square already we have, that is a 0.96, means the accuracy on the train data is 0.96, but I want to check how this model will perform on unknown data. Okay, so we will calculate the R square. So before that we need to calculate the RSS. What is the RSS? Means residual sum square. So can you calculate the RSS quickly? Can you calculate the RSS? Okay, so can you calculate the RSS for this test data? Can you calculate? What is the RSS? As you can say, the residual sum square. So what is the actually first what we need to do? Here we need to calculate the prediction y pred. Okay, so what will be the prediction here? So you can say what is the equation? That equation is 0.0321. Okay, there I will pass the x. X means what? 320 plus what I will pass? 175. So that is a prediction. Okay, and here what I will do again, 0.321, I'm sorry, 321 into x. X means what here? X is nothing but 5000 plus 175, and even I will make this dynamic. I will pass this x value plus what? Sorry, this is not 120. Sorry, this value and this, and here actually 0.0321. Okay, so these are the y prediction. Okay, so what I will do to calculate the RSS, what I will do, the gap between the, in short you can say what is the actual value and what is the predicted value on test data. Okay, so what is the predicted value here? 319.45 minus what? Minus 320. Okay, square plus 350 minus 335.5. Okay, so what's the residual sum square here? That is the, you can say the 210.553. Okay, now we will calculate the total sum square. What is the total sum square? How to calculate? Okay, so what I did here means you can see the I calculated the residual sum square. How to calculate the residual sum square? Means in short you can say first means on the test data we will identify what is the prediction, and we know actually means I'm just assuming the test data is the unknown data for this model. I'm passing this data and I'm just want to predict. So here you can see 320, 350, that is the price already I have. So that is the actual value of the price of that home, and this is the y prediction. Y prediction is nothing but 319.45 and 335.5 that I calculated with the help of what? If I quickly show, okay, so if I quickly show the formula, this the formula means in this particular equation I pass the size, then I can calculate the price, right? So I am passing x is equal to what? You can see x is equal to 4500. If I pass x is equal to 5000, then what will be the prediction that I calculated, right? The next point, on this test data you will calculate the R square. Okay, and how to calculate the R square? means this is the formula 1 minus residual sum square divided by total sum square, or you can write in this way. Okay, now I'm just trying to calculate here. If you see the formula, is what I'm trying to do. The gap between is 319.45 prediction minus actual square plus prediction minus actual square, means for the second data. So that I did here, and I'm getting the residual sum square. Okay, so now what is the total sum square, means the average. What is the average of the all data? Actual data is 335, so that is nothing but the y bar. And what is the actual value? So now if I see, so here means what you will do, 320 minus 335 square plus 350 minus 335 square. Okay, then you will get 450. Now you will calculate the ratio between the residual sum square divided by total sum square. That ratio is 0.46, and 1 minus this is equal to the r square value. So that is the, you can say, accuracy on test data. Accuracy on what? Test data. Now issue here, okay, what is the issue here? Means it gives the 96% accuracy with the trained data, but when I pass the some unknown data in this particular model, I am getting the accuracy only 53%. So what type of the problem here? Okay, so suppose just assume that okay, I will pass one image, 1 minute. So now the condition is like that, 99% accuracy with the training, but actual accuracy means with the unknown data is 39%. So in real life, can you use this particular model? No. And what is the problem here? This particular problem is known as overfitting. Okay, this is the overfitting of the model. It will give the good result with the training data, but it will not give the good result with the testing data. That's the thing. So this is about the linear regression. But how to reduce this overfitting, how to reduce the underfitting, so that all the thing also we discuss. Okay, I quickly try to discuss this particular point. And suppose just assume that train and test accuracy. Just assume that the train accuracy is 96% and the training accuracy is what, 36%. It means what? It means it's underfitting. It's underfitting model. Okay, if the next point is accuracy with the trained data is 39% and the test data is again 35%. It means what? I'm sorry, this is the overfitting. I'm so sorry. And it means what? This is the underfitting. And we need to actually find out some model, or you can say the general model which we can use in the real life. Okay, so that type of the model we require, that maybe you can say that it shows 85% accuracy with the train and it shows the approx 80% accuracy with the test, then I will accept, and that is the general model. Means 80% time it will give the right result with the unknown data. So that type of the model actually we require, and for the prediction purpose, and then we can use that particular thing in the some real life problem. Okay, so that particular thing we can use in the real life problem. So that's all about the linear regression. Even we will do this linear regression part in the next session with Python. Means that is also very easy programming language. So there we try to do this particular thing. I hope this will be helpful to you. Thanks.